Hello. So here I'm going to do a little, hopefully short video about using Newton's method to find the root to an equation f of x equals 0 in general, but here we want to find the square root of 3. So the first thing I want to do is x squared is 3, or x squared minus 3 is 0. If I have a square root of 3, it satisfies x squared is 3, or x squared minus 3 is 0. So that gives me the f of x. So my f of x is x squared minus 3, and that's the function I want to find a 0 of. Maybe I should draw the picture. It looks something like this. This is y equals x squared minus 3. Here is square root of 3. Here's negative square root of 3. All right, so I want to actually find that solution with a positive x. All right. Okay, I'm a little bit off the page. So. All right. So what I need, I'm going to use Newton's method. I have an initial guess, x naught. I know my formula f of x now is f of x is x squared minus 3. And that's often the key is finding the function I want to find the 0 of. I want to solve f of x equals 0 for x, okay? But this is a particularly easy function to differentiate, right? So in this case, it's going to be xn plus 1 is going to be xn minus xn squared minus 3 over 2xn, right? That's what Newton's method in general is applied to this f of x. All right, and I can make a little table in xn. x0 is, well, what's x0 going to be? Well, just to make it easy, I know square root of 3 is somewhere between 1 and 2. Let's just make it 2. I could choose anything, actually. Any positive number will actually work for this case. So what's that going to be? I get 2 minus 2 squared minus 3 over 2 times 2. That's going to be 2 minus 4 minus 1 is 1 over 4. That's 1.75. Well, I don't want to have to be doing this too much. So let's use some computer help, okay? I have here, I'm going to start sharing the screen. I'm going to share the, yes, I've got a spreadsheet. Here is a Google spreadsheet, okay? Let's start with, let's just make this, let's do some tables. There's going to be n and here's going to be xn. I don't really need to do this, but it's kind of nice. So let's start with, and this, what I'm going to do here is the real key to how it works. I can say that the next cell is going to equal, I put the equal sign, it's going to be 1 plus the previous guy, okay? Look at that is 1. So in fact, now I can just keep doing that down. You see that? So what it does is like the cell 4 says cell 4, sorry, sorry, this is on cell 6. 6 is 1 plus A5. A6 is 1 plus A5. A12 is 1 plus A11. It just always works. I only put it in the first one, and then when I come down, it automatically fills in the rest. So I'm going to do the same thing on that for xn. Actually, I'm going to call that x sub n. This is like what we often do for a subscript. So my first guess was x sub 0, x naught, and that's 2. And that's when I enter. What do I do here? This is going to equal the previous x minus, in parentheses, that the previous xn all squared minus 3 divided by 2 times x, the previous x. Now, I'm not sure if I need to use a time multiplication symbol there. I think I'm going to just for fun, just to be sure, not for fun, but to be sure. So I got, oh, look at that. I got 1.75 just the way I did in by hand. That gives me some confidence. And by the way, when was George Washington born? Anybody remember? 1732, right? The square root of 3 to a very good approximation is 1.732. But also look at how quickly Newton's method works, right? The first guess was 2, 1.75, 1.7321, 1.73200. And then it's a little bit different, but at least x3 and x4 are a little bit different. But to this accuracy, x4 and x5 and x6 are all the same, right? And you notice I can put in any number. Let's just put in like a 1 here. And then after I do 1, then the next guess is 2, then 1.75, the thing repeats. I could put the guess be, I don't know, let's make it 100. Takes a little bit longer if I do the guess of 100 to eventually get down to xn approaches 1.732 ... as n goes to infinity. That's the way I get the solution. Okay. All right. Bye.